Let us now imagine we have this just a person starting here, and each second they travel in this direction, each second covering 1 meter. And we have a second person who covers 2 meters each second. And we have a person who covers 3 meters each second. Like so. Now, if we were to graph these, we have our velocity in meters per second, and we have our time in seconds, and here's our 0 point. Now, to get the values here, let us start with the first person. The velocity is delta x over delta t. Well, let's see. Delta x is xf minus x0 over delta t. The final position is 1, right here, and the initial position was 5. So 1 minus 5, and it took 1, 2, 3, 4 seconds. So we have -4 over 4, which is -1 meters per second. Now that should come as no surprise. We know that the change is in the negative direction. The position is changing toward the negatives. The direction is opposite the last examples. The other was positive direction in the previous sets of examples, and this is negative. So that means the velocity is directed negatively. So what this amounts to on the graph, -1, -2, -3, is that first curve remains a constant and steady -1 meter per second. Well, then after 1, 2, or 3 seconds, if we were to find the area, we would discover that the area is 1 times -1, or -1. The area is negative. We have negative area. Well, negative area, what does the area mean? The area means the displacement. So we have negative displacement. Oh, in 1 second, the displacement changed by 1 in the negative direction. And after 2 seconds, we have -1 times 2, or -2. The displacement is 2 in the negative direction. Plotting the other graphs, we had the second one that was at 2 meters per second, the blue one, and we had the orange one that was at 3 meters per second, -3. So what these graphs show is a constant velocity. The velocity does not change as time goes by. What does change is the displacement. The position changes, the displacement changes, and the displacement can be found by the area. So now let us consider the case of a changing velocity. Let us suppose that we have a person starting here, and in the first second, they travel to this location. And then in the next second, they travel in this location. You can see that in this second, they didn't travel as far as they did in this one. And in the next second, they travel that far. And in the next second, they travel this far. So we have 1 second, 1 second, 1 second, 1 second. And we have a displacement of +1 meter, 2 meters, 3 meters, 4 meters. Well, to calculate the velocity in these cases, we'd have velocity equals delta x over delta t. Our final position is -4 minus a -5 all over 1 second, which gives us 1 meters per second. And you could see here that the denominator will change to 2. So we have a speed of 1 meter per second, 2 meters per second, 3 meters per second, 4 meters per second. The velocity is changing. So we have velocity in meters per second, and we have time in seconds, and this is our 0, our origin. So what we see is that at time 0, we don't really have a velocity, but at the end of time 1, we see the velocity is 1. And at the end of time 2, we see the velocity is 2. At the end of time 3, the average velocity had been 3. And at the end of time 4, if my graph paper were a little larger, it would go there. So what we could see is, I put some point protectors on, these like so, we get a straight line. And not just any straight line, a direct relationship. This shows that the velocity is increasing at a constant rate. It is a straight line, the velocity increased at a constant rate. And now you could see up here, each second I increase the speed by 1 meter per second. So this is what it looks like when an object is changing its speed. Now, the word we use when that we associate with changing speed or changing velocity is acceleration. This person is accelerating as they move along this number line. You can see that the velocity is increasing and getting positive like so. So in the previous slide, I said there are 3 things for us to always look at on a graph. First of all, what can we read? And in this case, we can read velocity and time. Then I said the next thing for us to look at is the gradient. We would come back to it. We're going to deal with that in a few moments. The area, we said, is the displacement, delta x. So what is the gradient? Well, the gradient is given by the equation delta y over delta x. The y-axis of our graph is velocity, so the gradient is delta v, and the x-axis is time over delta t. It's the rate of change in velocity. The gradient in this case is the rate of change of velocity. So if we were to compute the rate of change in velocity, we could actually do a delta v. It ended at 3, started at 1, so we have 3 minus 1 over 2 seconds is the time interval. We end up with 2 over 2, or 1. The gradient is 1. Well, what was happening by 1? What was happening is the speed was increasing by 1 meter per second every second. This is 1 meter per second. This is 2 meters per second. This was 3 meters per second. And this was 4 meters per second. So every second, the speed was increasing by 1 meter per second. Now, to find out the real meaning of this, we should do some dimensional analysis. So what are the units of gradient? Well, change in velocity, if I'm subtracting 2 velocities, 3 meters per second minus 1 meters per second, gives us 2 meters per second. So 2 meters per second, and the time is second. So 2 meters, we had 1 meter per second is what we came up with, was the number. But the point is that we have meters per second. How many meters per second was it changing every second? Now, what that yields is meters per second times 1 over second, which is meters per second squared, or ms minus 2. Those are the units. Now, meters per second squared is an algebraic contrivance because it's meters per second. It's just like as 1/4 is divided by 4, that's 1 over 4 squared, which is 1/16. It's not something very particularly special. But it turns out, notice this is not the units of velocity or speed, it's the units of something else. It's the units of the rate of change in velocity, which has a name, acceleration. So the gradient of this graph gives the acceleration, how much the velocity is changing every second. So a lot of information on a velocity time graph. We can get the velocity and time values. The area will give us the displacement, and the gradient will give us the acceleration.